Hello. In this video, we will be extending our lecture to support other tokens as well. In the previous video, our lecture was only scanning for opening and closing parentheses, opening and closing braces, but now we need to add support for all the other single character tokens as well. So let's just read what they tell us to do. You will add support for scanning other single character tokens, namely comma dot minus plus semicolon star slash is and star and slash is not covered here. It's covered in later stages. All right. The code for this stage is implemented in this. You can read through that. I don't need to, or you can watch my video. The tester will run a series. So will run a series of tests with a test.logs that contains parentheses, braces combined with these new single character tokens. Okay. So let's just let's just try to run this code on our local system as well so that we can test before pushing to code crafters. So this will fail because I haven't provided any runtime arguments. I just needed IntelliJ to create a configuration for me. Now I can come here and edit it, but before editing it, I need to create a file called test.logs. So what I'll do is I will create here test.logs. I'll open it in Explorer, copy the path. Now I can edit the configuration and I need to pass it two arguments. First is the command, then the path of the file, and it's test.logs. I can apply and run. There are no tokens inside of it right now, so EOF null. Let's just paste the string that they have provided us so that we can test our code before running it. Now if I run it, I'm going to see some errors. Specifically, I don't think I've added any errors right now. I think it should pass, but it won't scan everything. Yeah, it scanned only braces and parentheses. So to extend our lecture further, we should first of all add all the token types, right? So we have left parentheses, right parentheses, and see, these are all the token types that they have given to us. All right. So now let me tell you something. The author of the book, Robert Nystrom, has not added ternary operator in this language. We'll do that on our own. I've done it, and matter of fact, it's a challenge in his book to do that yourself, and I solved it, so I'll add it in this playlist as well. So there are going to be a couple more single character tokens like question mark and colon. They only have semicolon, they do not have question mark here, but we'll add that on our own because I want my language to have a ternary operator. So we need to add all these types to our token types. So let's just segregate them first. So right now all we are doing is handling single character tokens, right? Character tokens. So we have left parent, right parent, EOF, left brace, right brace. Technically EOF is not a single character token, it's a zero character token. Doesn't need a category. Anyways, left parent, right parent, left brace, right brace. Then we can have comma, dot, then minus, plus, semicolon, and then I'll add colon for the ternary operator and question for the ternary operator. And even though they tell us to not add in this stage, let's just add its token type at least. I know it's going to be star and we know it's going to be slash. Now the interesting thing about slash is a slash may not necessarily be a single character token. It may be a two character token. How so? Because a slash serves as a division operator, but a double slash serves as a comment, and a slash with a star serves as a multi-line comment. The author of the book has not written the code for multi-line comments. He gave that as a challenge as well, and so we'll do that as well. He only gave single line comments and not multi-line comments, but we'll add that on our own. The interesting thing is that slash is not a single character token. It's not necessarily. It may be a single character token. Maybe single character token. But it's we're not sure if it's not. What other tokens fall into that category? So an exclamation mark is a negation, but an exclamation mark with an equal to is an equality operator. So we don't know whether an exclamation mark or a bang is a single character token or not. So it may be a single character token. Then the same goes for equal to. Equal to is an assignment operator, but double equal to is an equality operator. So an equal to may again be a single character token, but we're not sure. Equality. Same goes for greater, greater than equal to, and same goes for less, less than equal to. So these five are special tokens. We don't know if they are single character token or a double character token unless we go ahead and check the next character as well. Okay, so these are those. And then we have a third category of tokens that we know are definitely multi-character tokens. Multi-character tokens. So let me just copy and paste that, and let me explain to you what those tokens are for. Okay, so these are the tokens. Let me go through them. An identifier will be a token for any variable name or function name. So that will be the purpose of the identifier token. Then we have strings for strings in logs, any string. So when we encounter and scan a string, we will add the token type of string to it. Same goes, I think it's self-explanatory. Number. Then we have and for and operator, and we have or for or operator in Java, which is this. In logs, it can be or, like in Python. Then we have classes. We have if and else. We have false and true for booleans. We have fun. Fun is a keyword used to define functions. Like in Python, it would be def. All right. And in JavaScript, it would be function. So in logs, we have fun. I think in Rust, it's fun, pub fun. I know, I'm not public function. I think so. I'm not sure. For loops, while for while loops, nil for nulls, print. To print something to the output, standard output, we use a keyword print, and so its token type is going to be print. Then we have return. To return out of functions. You guys know what a return is, right? And super is going to be used for inheritance. Our interpreter supports inheritance as well, inheritance between classes. You know what this keyword is, so this is the token type for this keyword. And var is used to define variables, like we have let, var, and const in JavaScript. We only have var in logs. Now the interesting thing is, you know that JavaScript hosts your variables. Where do you think we should do that? Like I showed you a diagram in the last video. Let me open that. So somewhere our interpreter must decide where to hoist the variables. Somewhere in our interpreter we should decide to hoist variables. Where do you guess it would be? So if you guess the semantic analyzer, you're correct. Semantic analyzer is the place where we will check for our grammar rules. So if some variable needs to be hoisted, it will happen before, after parsing, but before interpretation. So in here, semantic analyzer, you can create a class that goes through all your variables and hoists them to the top of the scope. So we do not have that in logs, but I'm just letting you know what semantic analyzers do. Anyways, so The author of the book again does not support break and continue to break out of loops, but I added support for them on my own, and I will show you how to do that as well. All right. So these are all the tokens that we need. We don't need any other tokens. And I think we made a typo in the last video. We made a typo. This name is incorrect. It should not be EXEC exception. Just correcting the name. Okay. So now that we have added all the token types required, we can start adding cases to our handle token method. All right. So right now we're only handling parentheses, and we need to handle. Give me a moment, guys. Yeah, we need to add cases for all the other single character tokens. So we'll be adding 1, 2, 3, 4, 5. So let me add that one. Let's just. So this is a semicolon. Then we have a colon. We have a question mark. We have a minus and a plus. We have commas. This is a comma. We have full stops or dots. Its token type is dot. Then we have minus and plus. Token type is minus. And we have a plus. Then, even though they tell you to not handle these right now, we can handle star right away. Doesn't matter. And let me add a comment for slash because it's a special case. We will update this case right here. All right. So this is now not how it should be handled. Maybe multi-character. What else can be multi-character? We have slash bang equality. We are not adding those right now. So this is not how it should be handled. We will update this code when we get to, where is it? Division operator. When we get to this stage, we will update that code, but right now it's fine. We can leave it like so. All right. That's, So right now, what happens if we add a, I think that's fine. That's the next stage. So let's try to push git add git commit -m. Git push. Let's see if it works. It works. Let's go to the next stage. We can mark this stage as completed. View the next stage. So now we need to add support for reporting errors when scanning invalid tokens. Dollars and hashtags are not supported. The code for this stage is implemented in. If you want to, I recommend it, but you can also watch my video. So they will try to tokenize this string. So let's just copy it, paste it to our test.logs. The tester will run your program like this, tokenize test.logs. Then two errors should be reported. Unexpected token for dollar, unexpected token for hashtag, And then we should tell the user all the correct tokens as well. So now this requires quite a bit of refactor. Errors should be printed to the standard error stream starting with line number prefix. And in case of an error, the exit code returned from a program should be 65. The tester will assert that the standard error stream contains one line for each lexical error if present. The standard output stream. So these things need to be printed to the standard output stream, and these things should be printed to the standard error stream. Since we haven't introduced new line characters yet, all errors will start with line 1. Okay. So now you see where that line comes handy. We have this, right? So it will be useful to report errors to users. So if we find any unsupported character, we can add a default case for it. Now we have a class scan exception, right? We can create an object of it, new scan exception, and let me, I think, update it. I do not need a throwable here. Simple exception is fine. We'll give it a message. So we need to add a line number, right? Line plus this plus, sorry, right here. Error unexpected character, and then we can add the character. So this is the error message that should be reported. All right. So let's just print it. System dot error dot print line. I can print e dot get message. And now the thing is, if I throw this error, it will break the control flow. All right, you know, right? The control flow will come out of handle token. There will be an exception here. The control flow will come out of scan, and then the runner calls the scan method, right? So right here, there will be an, if I throw the error, the control flow will come out of here and will go into a catch block if I add it. But I don't want that. See, it's not necessary that this may be the last character. So there may be a valid character after an error. So we need to keep on scanning even though we encountered an error. Why is that? Because let's imagine any user, let's suppose you wrote a JavaScript script, and there are multiple compilation errors. So when you try to run it, would you rather get one error at a time? Like you get one error, then you fix it, then you again run, then you get another error, then you fix it. That's not very handy, right? So it's good to report all the errors upfront. So that's why we need to keep on scanning even though we encounter an error. So to be able to do that, let's go to our Lexer. And in this handle token, it's right now returning void. Let's just return the error. Okay, so if we are here, I can return the exception. And if you are outside of the switch case, I can return null. All right. So right here, I'm going to get an exception. Scan exception, current exception. And what's the issue? Result is not thrown. And if the current exception is not null, I need to do something with it. Exception is not equal to null. I need to do something, but what? If my scanner finds an exception, it should stop the interpreter. So like I showed you that, let me open it again. So this is a scanner. So if I find an exception, I should keep scanning and reporting all the errors, but our interpreter should not proceed forward with the next of the steps, right? We should not go ahead with pre-processing. We should not go ahead with parsing. We should not go ahead with semantic analyzing, and we should not trigger our interpreter on the code because the code is wrong. So when we encounter an error, we need to tell our runner class that you need to stop executing it. All right, and that can only be done if I return the error from here, because uh, the runner class calls this method, right? The scan method. So I need a way to be able to return this error back to the runner class, and in here I will decide if we have an error. I will not proceed forward with uh, I will not proceed forward with pre-processing and parsing and interpretation, but I will stop the processing here. So I need the exception returned from that class to here, and this is where the go type errors as return values is very handy. But we need to do something in Java to be able to achieve that. What I'll do is I will create a public static result class, public static class result, and it will have a private public final list of tokens, because see, my scan method was already returning a list of tokens, and I still need to return the list of tokens, but I also need to return an exception if there is any. So tokens, all right, and then we have a public final exception, and I can create a constructor. So the errors are already reported to the user. I just need a way to be able to stop the execution in the runner here. So if my scan now returns a result, I can expect the result right here. So it should be uh, result, and it will be in result.tokens. All the tokens will be in result.token, and if result dot exception is not equal to null, in that case I need to stop the program with the error 65 code, right? So system dot exit 65. So we exit out. So let me do it early return here. If file content dot is empty, in that case we do this and return, and otherwise I will do this. Okay, so if result.exception is not equal to null, in that case we exit out of the program with the error code 65, but this will print all the tokens, and our error message is also reported on the error output stream, error stream. I think we are good. No, right here. If the exception is not equal to null, what I need to do is I need a variable outside scan exception is exception equal to null, and if current exception is not equal to null, I will set is exception equal to current exception, and instead of returning tokens I will return a new result of tokens comma is exception. So I think you can use a boolean as well right here, but we are already creating an object of exception, so I think we're fine returning the exception. So if we do not find an exception, is exception value will be null, right? And then we'll return the is exception to the runner class, and in here I will check, I'm checking if it's not equal to, if it's not equal to null, then that means there was some exception, and in that case we can exit out of our program with the error 65 code. Let me check if everything is fine according to my notes for this video. Yes and yes and Yeah, I think that's it. So let's try running it. We have the test.logs set up. So we printed two errors and we printed as required of us. I think it's working fine. So let's try to push to code crafters, git commit, git push. Let's see if it works. So there was some error. EOF, unexpected character. Skipped one lines that didn't start with line N. Expected line number one. Oh, haha. I know what the issue is. Add an empty space right here and it will work. So this line variable is going to be very useful. But right now we're not incrementing line, right? So can you guess how this line would be incremented? Uh, it's quite simple. We'll add a case for a new line character. And if we encounter a new line character, we simply increment line. We'll fix it in the later videos. It's not required of us right now. I will fix it and let you guys know. But in the meantime, you're free to try on yourself. Try by yourself. So I guess that's it for this one. Our think, yeah, we passed the test. Okay.